Hello, I'm Chris DiMartino, a Sales and Applications Engineer at Modelithics. Welcome to this video on utilizing the tolerance parameter within Modelithics models in Keysight ADS. Modelithics microwave global models in ADS include a tolerance parameter that's intended to be used for Monte Carlo and yield simulations. In this video, we'll focus on this model feature and explain how it can be utilized for tolerance analysis. Let's start by looking at the microwave global model for the Passive Plus 0402N capacitor series. We can see the tolerance parameter here, which is set to a value of 1 by default. This parameter functions as a scaling factor used to center the part value on a specific value. For example, let's say we have a 10 picofarad capacitor and we set the tolerance parameter to 0.91. That would change the capacitance value to 9.1 picofarads. However, although the part value scales with respect to the tolerance parameter, the parasitic characteristics remain unchanged. We'll look at this in more detail later. Let's click the Setup button, and then we'll select the Statistics tab. We'll enable this, and then notice how we can select different statistical value types. We'll go ahead and select Gaussian. We can also choose a statistical value format. In this case, we want to specify the standard deviation as a percentage of the nominal part value. So we'll go ahead and choose that option, and we'll set the value to 5%. Note that the capacitor is set to 10 picofarads. Now let's perform a Monte Carlo simulation of this capacitor model. We have here both an S-parameter controller and a Monte Carlo controller. We need to set the sim instance name parameter of the Monte Carlo controller to the instance name of the S-parameter controller. Let's also leave the default number of 250 iterations. Make sure to set the Save All Iterations parameter to Yes to view the results of each iteration. Let's simulate this, and now you can see the S11 results for all 250 iterations. Now you may be wondering why we even need to use the tolerance parameter in the first place. After all, we could just select the part value of the model and then configure the statistical value parameters the same way we just did. However, this approach would not only vary the model's part value, it would also vary the model's parasitic characteristics as the part value changes. So this analysis may not be completely accurate because component parasitics are varying along with the part value. In contrast, varying the tolerance parameter only causes the part value to vary. The parasitic characteristics do not change. So what this all means is that utilizing the tolerance parameter for Monte Carlo and yield simulations allows for a statistical variation of the part value alone. Therefore, the tolerance parameter should be used for these simulations. Let's continue by looking at a simple low-pass filter that consists of a series inductor and 2 shunt capacitors. For the inductor, we have a microwave global model for the Coilcraft 0402CS series. For the capacitors, we have microwave global models for the AVX UQCL series. Here are the simulated S parameters of this filter. Now let's configure the statistical parameters of each model by utilizing the tolerance parameter like we demonstrated earlier. Again, we'll set the statistical value type to Gaussian for all models, and again we'll set the standard deviation to 5%. Let's now run a Monte Carlo simulation. Again, the number of iterations is set to 250. And here are the simulated S21 and S11. Now so far, we've only looked at Monte Carlo simulations, which allow us to see the spread of the circuit response due to component tolerances. Let's now look at yield simulations, which allow us to determine how many design iterations will meet a given specification out of a specified number of total iterations. Let's go back to the same low-pass filter example we just looked at. The schematic is set up for a yield simulation. we have a yield controller, and a yield spec component. We have our yield specifications, which in this case is an S11 of less than -20 dB from DC to 1.45 GHz. Again, we'll go with 250 iterations. We can now run the analysis. After the simulation finishes, we can add a table here. We'll select yield along with the number of passing and failing iterations. Let's also add our S11 and S21 plots. We can see from our table that 167 iterations out of 250 passed by achieving an S11 of less than -20 dB from DC to 1.45 GHz. Therefore, the passing rate is 66.8%. In conclusion, we've demonstrated how to perform Monte Carlo and yield simulations in Keysight ADS with Modelithics microwave global models. Note that this video is based on Modelithics Application Note 75, which you can download from the Modelithics website. You can also visit the Modelithics website to request a free trial, or you can email sales@modelithics.com.